This video will include the Unit 7 review questions to help you study and prepare for Test 3. For all problems when we are finding probability, we will write our answers as a simplified fraction, a decimal rounded to the nearest hundredths, and a percent. For our first problems, we're going to use the universal set, the letters G through T. Set A is going to be J, K, L, M, N. Set B is going to be M, N, O, and P. So we want to find the set A complement. That little C means complement, which pretty much just means not in set A. When you're finding the complement, you're not in that set. We're going to use set notation because it's going to be a set of elements. So the values that are in set A start at J, K, L, M, and N. Be careful that you don't just think that set B is the ones that are not in set A. We have to go all the way back to the universal set and notice that G, H, I, J is the first letter that is in set A, so J, K, L, M, N. So then we're going to pick up with O, P, Q, R, S, and T. Do not just assume that when we say complement of A that we mean B. We want to know what's not in set A out of our universal set. Let's find now the set of A and B. This symbol, we can read it as the word and, or it actually means the intersection. So we want to know what's in A and B. Look at your set A, look at your set B. The elements that are in both A and B would be M and N. They show up in both A and B. So our set would be M, N. Of course, if we've drawn a Venn diagram, we could see that intersection because those would be the letters that show up in both. In that overlap of a Venn diagram, the intersection is this part here. This would be our set A, this would be our set B, and A and B would be that intersection. Let's look at our next question, number 5. We have 2 8-sided dice are rolled. Find the probability of rolling a number. So here's our first one, a number less than 4 on the first die, and an 8 on the second die. So let's first talk about that number less than 4. So an 8-sided die has the numbers 1 through 8. If we're talking about the numbers less than 4, well, that will be 3 of those numbers because you do not want to include the number 4. It's not less than itself. So just 3 numbers out of the 8 sides. Because it says the word and, we're going to multiply our fractions. So we're going to multiply that with an 8 on the second die. Well, there's just 1 8 out of the 8 sides. So 3 out of 8 is your chances of getting a number less than 4. And we multiply 8 on the second die. There's just 1 out of the 8. So now we take and we can multiply those fractions together. Do alpha y equals, or you can just use division. So alpha y equals, and we have 3 over 8. We're going to multiply that with alpha y equals the 1 over 8. So that gives us 3 over 64. If we want to change that to a decimal, here with the fraction in our calculator, we hit the math button, the option 2, so you can arrow down and enter, or you can just hit the numeric key 2. That fraction to a decimal. If we round it to the nearest hundredth, that's 2 decimal places. So that 6 would make this round up. We have 0.05. So our percent If we multiply that decimal times 100, we get 5%. So that 0.05 times 100, you can see that's 5%. Let's now look at question 6. We're going to roll a 6-sided die and spin the spinner to the right, so this spinner here. What is the probability? So here we are, the die lands on a 4 and the spinner's going to land on red. Let's first talk about this being on a 4. Because we have a 6-sided die, well, there's a chance of 1 out of those 6 sides that we actually get a 4. Do not confuse and think it's 4 out of the 6. There's only one of these 4s on that 6-sided die. And, so again, we're going to multiply when we see the word and. The spinner lands on red. So we've got 1, 2, 3 sections that are red. So 3 out of, we want the total of how many sections we have. So there's 3 out of 6. And then again, we can multiply those to change to our decimal and percent. So alpha y equals, we want 1/6, and we're going to multiply that with 3/6. That reduces and gives us 1 out of 12. The calculator is multiplying the numerators and denominators, and then it's already reducing it for us, so 1 out of 12. Change that to a decimal, hit Math, Decimal, which is option 2, and rounded to the nearest hundredths. This is tenths, hundredths, it's 2 decimals. That 3 will not make this round up. So we're going to leave it 0.08. So that makes it 8%. We can take that decimal and multiply by 100. Percent is per 100. So that's how we get the 8%. Let's now go to question number 9. This table is just a random set of data. Notice it will not match your class data. Just understand how we set up the probability. Of course, you could recopy this table if you would like, so you could follow along with this example. So we're going to find the probability that a right-handed student has blue eyes. So because it narrowed it down to right-handed students, we're only going to be looking at this group of students. We really don't even care that 35 students were in the class, because finding the probability that are right-handed students, those are the only ones that we're going to be looking at. Well, the ones that have blue eyes, there are 12 out of the 31. There's no other calculations that we need to do. We don't need to add or multiply anything else, because it just wants to know the probability that a right-handed student, so this group of students, has blue eyes. So that was 12 out of the total 31. So 12 out of 31, if you hit Math Fraction, notice it does not reduce. So changing that to a decimal, Math Decimal, gives us to the nearest tenths, hundredths. That 7 will make this round up. So 0.39, which gives us 39%. So finding the probability that a right-handed student, in this group of right-handed students, 39% of them have blue eyes. Let's look now at our next table. Again, you might want to copy this table to match the examples I'm doing now. It will not match your class data, because this is just a random number of 40 students, which would be a very large class. So this is just a random set of data. It will not match your classroom data. What is the probability that a randomly selected student is female or prefers blue? So remember, with the word or, we're going to add when we're finding our probability. We might also have to subtract depending on if there are people that are female and prefer blue. So let's walk through this. We We have the probability that a randomly selected student is female. So here's our group of female students. There are 20 out of the total 40. Or, so we're going to add that with the students that prefer blue. So that's 20 out of 40. So notice if we stopped here and added these fractions together, we would say that we had 100%. 20 out of 40 plus 20 out of 40 would give us 40 out of 40, and that would be 100%. And that's not true. What's the probability that a randomly selected student is female or prefers blue? It was not 100% of the class. So we will have to subtract these students that are female and prefer blue. So subtract the fraction 9 out of 40. When you see the word or, it does mean to add, but because there were students that responded that were both female and prefer blue, we must subtract that intersection of both of those situations. So let's calculate our probability now. So we want to do alpha y equals, do 20 out of the 40. We're going to add that with alpha y equals, again, 20 out of 40. But now we need to subtract the 9 out of 40. So we get 31 out of 40. That as a decimal, so hit math, option 2. We'll change it to a decimal, rounded to the nearest hundredths is 2 decimal places, so that will round up. We have 0.78, so 78% are students that are female or prefer blue. So that's a pretty high number, but if you take a look at your data in your table, the highest response to our favorite color was 20 for blue, and it was 50-50 male-female. But in order to find the probability that a randomly selected student is female or prefers blue, we have to find the chances that a female plus preferring blue and subtract out that intersection of female and preferring blue. Let's look at our question number 12 now. We want to find the probability that a student is male given they prefer the color red. So let's actually highlight that in a different color. Because it says given that they prefer the color red, here we're only going to be looking at this group of students. We really don't care about anyone else in the table. We only care about the given group, the ones that prefer the color red. So we want to find the probability that a student is male. So finding the probability of a student that is male given that they prefer the color red. Well, because we only want to look at this group, we have 7 students, so that's our denominator number, that prefer the color red. So of that group, the ones that responded that were male, we have 3 of those students. So 3 out of the 7 are males. Given that they prefer the color red, we only had 7 students that prefer the color red, and the chances of them being a male, there were 3 out of those 7. That fraction will not reduce, so 3 out of 7 gives us a decimal rounded to the nearest hundredth place, so tenths, hundredths. That 8 will make that round up, so we get 0.43. That makes it 43%. So given that they prefer the color red, 43% of them, so notice that it is fewer males than it was female, 43% of them were males that preferred the color red. Of course, you can complete the entire Unit 7 review to help you study for probability on Test 3.